Hello everyone, in this video let's discuss how to write a program to convert sorted list to binary search tree. Given the head of a singly linked list where elements are sorted in ascending order, convert it to a height balanced binary search tree. Let's take example 1. Here they have given a list of 5 elements. I need to convert this list into a binary search tree. So here the binary search tree is 0, -3, 9, -10 and 5. And there is another alternate approach. This is also considered to be a correct answer. Let's take the second example. If the head is null, which is if the list is empty, I have to return the empty list. So the logic is pretty simple. So what we'll do is, first we'll be check the base condition. So what the base condition will be doing? If head is equal to null, what I have to do? Directly I can return null. Fine. If the list contains only one element, what I have to do? So I will write this commands. If list is empty, I have to return null. If list has one element, so if I have only one element, I have to take that particular element that has to be inserted in binary search tree. So for that, if head dot next equal to null, if I have only one element, what I have to do? I have to create a tree node. So return new tree node. I have to create a tree node with the value which is present in that particular node. For that, I have to pass head dot val as my argument. That has to be written, which means binary search tree has only one element. Fine. If I have more than one element, for that what I have to do is, I have to take the list and I have to find the middle element. So middle element can be calculated by using slow and fast pointer technique. So first I'll take list to node slow is equal to head and list to node fast is equal to head dot next. Fine. I have to take a while loop. Fast not equal to null and fast dot next not equal to null. If this condition is true, what I have to do? Slow has to be moved by one step. Slow equal to slow dot next. Fast has to move by two steps. Fast equal to fast dot next. That's all. Now we would have got the middle element. So the list has to be splitted into two halves. The middle element has to be taken from the list. That has to be inserted in binary search tree, and left list will be splitted into one half, and the right half of the list will be splitted into another half. So for that, tree node root is equal to new tree node. So middle element I have to take. So for that, slow dot next dot val. So middle element will be taken. That value will be inserted into the binary search tree. After this, the list has to be split into two halves, right? For that, left half, we know head always point to the first node. That will be the starting point of the first node. I need to know the right half. For that, list to node right is equal to slow dot next. I have split the linked list into two halves. Now I have to make slow dot next is equal to null. In the first half of the linked list, last node's address part has to be made it as null. That I have done here. After this, what I have to do? I have to call the recursive call for left child and the recursive call for the right child. For that, root dot left is equal to, I am going to call the recursive call sorted list to DST. So when I am calling the recursive call, I have to pass the first element of the list, that is first element of the first half of the list. So head will be passed. Now for the right child, root dot right equal to sorted list to DST. So here what I will be doing is sorted list to BST. I have to pass the right half's address because right half's first node, right? So I'll have to pass the right. That's all. Finally, I have to return the root value from the method. So it is similar like merge sort. So splitting the list, and that middle element will be taken. That will be inserted into the binary search tree. That's all. This is the logic of the program. Let's run the code now. Yes, it passes test cases. Let's submit the code. Yes, it passes all the test cases. That's all.